Okay, we've now seen a mechanical description of evaluation of procedures, both what happens when we define them and what happens when we actually use them, when we do a computation where we use the body of the procedure. We described a mechanical way of using environments. Let's look at a couple of examples to really drive home that process. Here's a simple example. Let's suppose I want to compute the power of some number to some other power, a to the power of p. I'm going to do it with just successive multiplication. I know that Python provides a built-in version of this, but I would say, for example, want to take a to the pth power, and I do it by multiplying a by itself, storing that result away, then multiplying that by a, then multiplying that by a, and just keeping track of how many multiplications do I need to do until I've done p of them, and keep track of the result and return it when I'm done. So here's some code to do it, and it's pretty straightforward. In fact, we just saw it earlier. It was my earlier example. I'm going to input some number for x. I'm going to input some number for p, and I'm going to make sure it's an int by doing a typecasting there. I'm going to set up an intermediate variable or a place to store the result, and then I'm just going to run through that loop where I'll print something up to tell me where I am, and I'll change the value of result. Let's look at an example to see that this does it. So if I go over to Python, I can load that computation in. It's now saying give me a number. I don't know, let's give it 3. It says give me an integer, let's give it 5. Oh, and it prints through the stages, telling me at each iteration what the current result is. It starts as 1, and then it's 3, and then it's 3 squared, and then it's 3 cubed, and then it's 3 to the 4th. Ooh, wait a minute. Didn't I want to take it to the 5th power? Well, notice that my print statement is just printing before I actually do the work. And in fact, when I'm done, what I've done is I've returned the value in result. And there it is, it's 243. Okay, we saw how that computation would take place previously. Now, let's capture it in a procedure. So I'm going to define a procedure called iterative power. There's the name. I'm going to give it 2 formal parameters, x and p. And then the body of the procedure is much like what I had for my computation before. I've got an internal definition of result, which I'm going to use. And the only big difference is when I am done with the computation of that for loop, I've got that special keyword return that says return the value of this expression, which is just the value of result, when I'm done. Let's try it to see if it works or not. I've already loaded this over here, so if I say I'm going to iterative power, I'm going to compute that. Let's do 3 to the 5. It runs through exactly the same stages, and notice what it printed out at the end. It printed out the value of the computation. And in fact, if I were to bind this, say z is equal to iterative power of 3 and 5, runs through the computation, and if I ask for the value of z, there it is, 243. So it does the computation I want. Now let's think about what happens inside of the environments. How does the scoping of the variables? So, if I were to evaluate that definition, which I did by loading it into my Python environment, what it does is it creates a binding for the name iterative power to a procedure object. And inside there I have the list of formal parameters, and I have the body. I also have an environment pointer that points back to the environment in which I did the definition, which we know we're going to use. If I now call iterative power with 2 and 5, what do we say happens? We get, first of all, the value of this expression, iterative power. It points to that. It's a procedure object. I get the values of each of these expressions with respect to this environment. Numbers are always numbers, so it's just 2 and 5. And then I create a new environment, which I'm calling E2. This new environment here, it has as a parent the environment that the procedure object has as a parent. And then inside of that environment, I bind these formal parameters to the values of the expressions passed in. And then relative to this environment, I now evaluate the body of the expression. And that's really cool. Because now I basically reduced the computation to a simpler computation. I'm now evaluating this expression, or sequence of expressions, relative to this environment. And that environment contains the bindings I want. So in fact, if I evaluate that body, what does it do? Well, the first expression it evaluates says bind result to 1. And notice where that happens. It happens down here in this environment. Not up in the global environment where I want to have some value. that I might want to think about is happening inside of this environment created by the procedure call. Having done that definition, I run through the for loop, and that says look up the value of x, which is right there, look up the value of result, which is right there, multiply them together, and change the binding for result. And then do it again, and again, and you get the idea. All of this computation takes place in this environment, E2. And what that says then is that the loop rebinds that local variable until we get to the exit, until when we're done and we hit that return expression. And return says look up the value of result in this environment, because that's where I'm doing the computation for the procedure. There it is. That's what's actually returned. Cool. That's exactly what I said it should do. Now, let's drive home a point. Imagine that we had actually done some bindings for x and p before we called it. In fact, let me go back over here to Python, and I'm going to say, let's set x equal to 3. Let's set p equal to 4. Let's set result equal to 5. And now let's call z as iterative power of, I don't know, let's make it 6 and 7. It runs through the computation, and notice what's happened. What's the value of z? Well, that is 6 to the 7th power. But more importantly, what's the value of x? Still 3. Value of p, still 4. The value of result is still 5. Those were bindings in a global environment. When I called the procedure, it created its own frame, its own context, did all the computation, and that local environment had separate bindings for x and p, which are not visible to the environment where we did the function call. So this point captures that notion of encapsulating the computation. And what that then says is, to say it in a little more detail, we have bindings for x and p up here. When we call the procedure, we do local bindings to the values passed in. We do local bindings for a result. And when we do that computation, the evaluation of the body only sees the bindings down here in E2. So we created a black box. Details don't matter. I can reuse this procedure anywhere by simply using its name. If I decide to change, for example, the names of the parameters in here, I'm free to do that, and it doesn't change any computation that relies on just using iterative power. So procedures do give us this wonderful notion of abstraction.